In this video, I'm going to show how you can use Capstone to analyze raw data that you might have collected in the lab, as opposed to data that's collected in real time with a sensor. So I'll click on Table and Graph, and the example I'm going to use for this video is I'm going to have I had a car go down an incline at different angles, and for each of those angles I know the acceleration rate, and I want to plot that data, acceleration versus angle, and I want to see if there's a mathematical model for that, some equation that best fits that data. So first step is to create my independent and dependent data category. So I'll click on Select Measurement, and I'll go Create New, and I'll go Angle and Acceleration. So this is my angle data, acceleration data, and I'll need some units here as well. So I'll say degrees, and rename this to say meters per second squared. Okay, so I'll put in some hypothetical data: 10 degrees, 20 degrees, 30 degrees. Oops, 10 degrees, 20 degrees. I'm hitting enter after each one of these. 60. I'm going to go over here and give this some hypothetical data: 0, enter, 1, enter, enter. Okay, so that's step 1. Enter my data. Okay. Step 2 is to create my graph. So I'm going to go to Select Measurement, and from the categories I just defined, I'm going to go plot acceleration versus angle. And I'll zoom it in with the first little button there, so I get a nice little graph, which should be linear. Okay. So there's my graph. The third step is to create a mathematical model for this, if you like. And the way you do that is with two different tools. You do it with the little selection tool, the yellow, looks like a yellow pen or pencil with some dots around it. And when you click that, you get a little draggable area that represents the region of interest that you want to analyze. So I'll click and drag it up here. So you can pick whatever data points you think are applicable. And the second step is to click the icon, what looks like a little line through it with some dots around it. And that gives me a list of different mathematical models. So linear, quadratic, cubic, powers, inverses, exponentials, and whatnot. So I'm going to go with linear, so I think it looks linear. And when I do that, I get a little box here with some values. M is the slope of the line, and the B is the y-intercept. So everything looks good there. Regression coefficient's 1, so it's a perfect fit. All right. And of course, if I go over here and let's say I change my data, let's say this is 0.5 meters per second squared, and this is maybe 5.5 or something like that. If I do that, you'll see that my best fit line got nudged up a little bit, and the values for the slope and the y-intercept changed, and my regression coefficient is still pretty good, but it also changes as well. So I can look at my mathematical model. So this is the way you analyze raw data that you might collect in the lab. Step 1, put the data into a data table, while defining your quantities. Create your graph. Use the selection tool and the mathematical model tool to develop or create your mathematical model of your data.